quick reminder, guys, that we have done in our lighting book, which is a little bit dated, but we went over different type of lamps. So hopefully that will kind of tap into it. I want to remind you, Aaron, my friend, this is not fixture. This is only lamps and ballasts. We're not talking about fixtures. Next chapter, we'll talk about fixtures. Here's a few things I would like to probably touch on today. Understand the technical terms associated with lamps and ballasts. So incandescent lamp, fluorescent lamps, LED lamps, induction lamps, high intensity discharge lamps. These are terminology, guys, when you graduate from Danuri, as well as now, you should be able to describe them and describe the best light for the application. We talked about this before, so we'll continue talking about it too. We remember we have a commercial project, and the commercial project have a lighting fixture schedule. So when you guys have a chance in the book, please look at their lighting fixture schedule that they have in the back of the book. We already have our own lighting fixture schedule that you guys created. Understand the basic of different type of fixture. We're going to start with the most basic one, the incandescent lamps. Then you throw a couple of gases inside it, make it halogen. Then we're going to go to the arc lamps, which is the fluorescent, the high intensity discharge, and then we will land into the LEDs. The most advanced fixture right now is the LEDs. So these are the types of lamps, 1, 2, 3, 4, 5 types of lamps, guys, that we're going to be talking about. And then with I don't know if you guys remember when we talked about this different type of lamps, we said these two lamps are called arc lamps, right? Because they require an arc. And every time you have an arc, Jeff, what do you need? You need a ballast, electronic or electromagnetic ballast. You need an electronic or electromagnetic ballast. So that's why we have to talk a little bit about electronic and electromagnetic ballast. Any comments, guys, about these? The different type of lamps and the ones that need electronics and electronic or electromagnetic ballast, the arc lamps. Okay, so that's a few things we want to talk about, my friends. Practical application of lamp used in the commercial. Remember, we have a project, and they're choosing some fluorescent lights to go in the project. So please look at these in your own time. Why? Because we already have our own project, commercial project, and we chose our own fixtures. If you guys remember, the troffers that we put inside and outside and all the stuff. So we're very familiar with this. Energy code, energy savings, and energy code for lamps and ballast. Every time they claim that 30 to 40% of your consumption of energy in a building is light. So if I can make an efficient light, I can reduce my consumption of energy and reduce my dependency on foreign oil. Now, did I start talking like politicians here? The only two things, well, one of the two things that you can control for an efficient lamp, guys, is the ballast, efficient ballast, and efficient lamp, right? You can also control efficient fixture, the frame of the fixture, and so forth. So the two decisive parts in making your fixture, if you look at this one above your head, Zach, my friend, to make this one efficient, the most decisive parts of making it efficient is two factors, the ballast and the lamps. Of course, the louvers and everything else will play a part, but between the ballast and the lamps, you got 90% of how efficient this fixture is, right? Everything else, comes as 10%. Okay, identify lamp types, different type of lamps that we're going to be using, certain characteristics for each, and the letter designation that they use for these lamps. The letter, you're going to see them. And finally, my friend, we in Bloomington, don't we have the house hazardous material where you can go dispose all your hazardous material in there? If anybody, I think most of the cities have. Oh, yeah, there is one there. I go there all the time. So the same thing, guys. Ballasts and lamps are hazardous materials, so you can't just throw them in your garbage. So that's we'll talk about this one, especially commercial ones. You'll be penalized for doing that. Okay, so a few terminology that I'm sure you guys are familiar with, and these are in a really nice format. Candela power. Does that ring a bell for you? We were using it yesterday. The candela power. That's the unit of measurement of the intensity of light. The unit of measurement of the intensity of light. So candela power, rating of the source, the intensity of light, the luminous intensity of the source, and they express it in candelas. Cool? Remember that CP that we used to have in that big formula? So this is like we measure currency in the US with dollars, right? We measure time with seconds. That's the unit that they measure light intensity. Can I have thumbs up, Chad? We used it? Perfect. Now, the problem is candela power. This is just the amount of light coming out of the fixture. I don't care about that one. I care about how bright the area is going to be when that amount of light hits the surface. Does that make sense, guys? The amount of light is candela power in lumens. When it hits the surface, it becomes foot candle. That's what the illuminance. Then you have the lumens. This is how they define one lumen, guys. A unit of, so it's the amount of light at a unit of time that can hit a unit of area at a unit of distance. So if you have a source of power here and an area here, all these are function. Here's the distance, here's the area, and here's the lumen, and what else? And the time. All these are factors in making the foot candle. And you guys have done it with me all the time. We've done it by hand and we've done it by visual, right? So we grab fixture, we put them at a certain height, we have a calculation zone, and it does all the calculation. Takes the lumens, throw that lumens over an area, and also the distance is a big factor. The further away the source from the area, the less light you're gonna get, right? So a lumen, the amount of light that hits a surface, a unit of surface based on how far the surface is from it, and for how long. Any comments, guys, about the lumens? So basically, lumens over area. Lumens over area, that'll get you the foot candle. Any comments, guys, about this? So lumens, here's how they define it. This is the technical term for it. I don't know if you guys can see this area here, right in this area here. And here's the source of power. It's in a sphere. Here's my point source. Here's the distance. This is my distance. This is my area. And this is my source of power. So if you take lumen, one lumen, over one square foot area, that will get you 1 foot candle. Any comments, guys? Any questions? Any comments? Any questions? So 1 lumen over 1 square foot, and if you want to take it also say 1 foot away from the source, that will get you a 1 foot candle. To summarize, without getting into all the science of it, guys, take the lumens, divide it by the area, you got yourself a term called foot candle. That's the illuminance, how bright the area is going to be. Can I have thumbs up, Chad? We understand. The smarter than Chad, they use differential equation to analyze the whole thing. But for simplification, guys, take the lumens divided by the area, you got yourself the illuminance. Okay, the illuminance. So illuminance is defined the measure of illuminance of a surface. So you take your lumen, like we said, take my lumen, divide them by my area, like we have done many times. That will give me my foot candle. This is the simplest form of it. Take lumens divided by area, got your foot candle. Of course, there's other factors, like we did yesterday. It's not as easy, simple as this. Which lumen, Chad? Is it the lumen coming out of the fixture, or is it the lumen bouncing off the wall and the ceiling and the floor? You guys remember what we did yesterday? We were taking lumens over area, but then when you dig deeper, which lumens and how far are the lumens from the surface? But the bottom line, the illuminance, so-called the illuminance, how bright the place is how many lumens you're throwing on a square foot of an area. Can I have thumbs up, Chad? We fully understand that. Everybody understand the lumen? That's a unit of measurement for light. Illuminance is the foot candle. How many lumens landing on a surface? On a surface. So that's the second term that I would like to emphasize, and we emphasized it before. There's one thing very important now. This is called lumen per watt. That's the efficacy or the efficiency of the fixture. We have a picture, guys, I want to show you. Because of energy code, Jeff, every fixture has a value that's called efficacy. How many lumens per watt this fixture can get? 20 lumens per watt or 100 lumens per watt? And Andrew, I'm not going to tell you something that you don't know. If you have a fixture that can throw 100 lumens per watt, that's much more efficient than a fixture that can draw 10 lumens per watt, right? That's mile per, what do you call it? Mile per gallon, like your car, guys. Let's pick on Andrew because he's living in Booney land down there. Andrew's driving a truck. His truck is 18 miles per gallon, right? Let's just pick on that one. And he maybe 14. And then who's the city slicker here? Joe, can we pick on you? Okay. Joe, city slicker, is driving a car that's 33 miles per hour, right? A Suzuki or a Kia? Is it 33? Okay, so that's exactly what the efficacy is. Everybody understand that one? It's typically the efficiency. The difference between the efficacy, Jeff, and the efficiency is the units are the same. Watt, mile. The efficacy, the units are different, like gallon, mile per gallon. That's efficacy. The same thing, watt, the unit is lumen per watt. They call them efficacy, but the concept is the same. How efficient the fixture is. Can I have thumbs up, Chad? The higher the efficacy of a fixture, the more energy efficient that fixture. And we use the energy code, guys, and I'm not going to convince you how important this factor is. We'll look at a table in a second. The second thing, because of the huggy-feely people, who's huggy-feely here? Adam, like my Adam, huggy-feely, or Darren? He doesn't look like huggy-feely, Darren. Okay. Because of the huggy-feely, the huggy-feely people, Kelvin, they have the temperature rating of the fixture. Temperature rating of the fixture, guys, make the light look cooler or warmer. Cooler means closer to the bluish, and warmer closer to the reddish. Does that make sense? Cooler and warmer. So they assign a temperature called Kelvin. Kelvin is, they use it a lot in science too, the Kelvin. Measure from the absolute zero. That's your absolute zero. Our zero, the Fahrenheit zero is zero, right? The freezing, the water freezing point is at 0 Fahrenheit or 0 Celsius, 32 Fahrenheit. So that zero is completely different. That's absolute zero. So equivalent to, this is equivalent to this amount of Celsius. This amount of Celsius. You can imagine 273.16. That's the 0 point. That's just the zero in Kelvin. And imagine that in Fahrenheit. If you change this one to Fahrenheit, multiply this by another factors, you have to change it to Fahrenheit. So who cares? You guys are going to care about one thing. The higher the temperature, the Kelvin, the more bluish the fixture will be, and the lower the Kelvin, the more reddish the fixture will be. The more reddish the fixture will be, the warmer the fixture will be. Who cares? People, guys, feel better under certain color. I have a picture that I'm going to show you. So be aware of the Kelvin rating of fixture. So 3,000, 4,000 Kelvin, and so forth. Color rendering index. Color rendering index is CR. Remember, guys, we talked about CRI. Color rendering index is, this is the ability of the fixture to allow you to discriminate or distinguish between colors. So you want to see the black and the green, right? A good fixture should give you all the colors, sharp cut between all the colors, right? So like your plasma TV and my old TV. Does that make sense, guys? So a good fixture have to have a higher color rendering index. Why? Because you need to distinguish between the black and the green and the blue. Can I have thumbs up, Chad? We fully understand that. Color rendering index. So ability of the lamp to portray object as they normally, as normally as possible without altering the actual color of that. Okay, so we got that one. Lumen maintenance. Lumen maintenance, there's so many things that affect the lumens, guys. How often the lamp maintenance, how often do you change the lamp lumen mortality, and how often you change your lamps, lumen maintenance. How long the lamps maintain its light output. That's a lamp lumen depreciation factor. That's equivalent to lamp lumen depreciation factor. If I have a lamp with 300 lumen, 3,000 lumens, would you think day one will be 3,000 and 2 years from now will be 3,000? If you think so, you don't know lights. Lights are like a human being, like Jamie and I. Over time, our efficiency goes down. Same thing with lamps. So ambient temperature, surrounding temperature affects functioning. Fixtures there, and my friend, they like certain amount of typically a lot of them, guys, they rate them for, I don't know, -20 to 100 or so. So but the closer to the ambient temperature, the further away from the cooler or the warmer, the too much cold or too much warm, fixtures will malfunction or will not produce the right lumens. Cool. So there is a certain operating temperature that the fixtures want to do. Some of them -20 Fahrenheit to say 110. I'm just throwing these numbers here, or in Celsius, 40 Celsius into say 40 Celsius to -10 Celsius to 40 Celsius. These are the operating temperature. The closer you get to being cold or hot, the less lumen that you can get out of the fixture, and more likely that the fixture will prematurely die on you. Any comments, guys, about the temperature? So temperature, ambient temperature, the best temperature for a fixture, guys, for the most part, is ambient temperature, room temperature. What is it, 78 or 25 Celsius, 78? Is that the room temperature? 78, 25 Celsius, 78 Fahrenheit. That's a good temperature for it. Okay. Now we're going to talk about a couple of things about the incandescent lamps. Incandescent lamps, you guys are familiar with incandescent lamps, low efficacy. These are heaters. We talked about these guys. You can literally boil a couple of eggs on them. You put one and you sit it there for probably an hour, it will boil an egg for you. Why? Because 80% of the energy consumed by incandescent lamps is heat. So if your intention is to heat your house, you use them. If your intention is to light your house, you don't use them. Does that make sense? So anyway, so that's why a lot of people use them, because they're cheap, they're low cost. In the US, again, I took my house and I changed all mine into compact fluorescent. I was a little bit disappointed though, because they're dying prematurely in certain areas. They really disappointed me. I think they don't like heat. I discovered if you have a basement, the basement gets hot in the winter. My basement, they don't like heat, and also they don't like humidity. Compact fluorescent.
Basement gets hot in the winter?
My basement, the area where I have them in, closer to the furnace, it gets really warm. And I noticed that I have a suspended ceiling, and I noticed that in that area, they are in a suspended ceiling, and it gets very close to the furnace, it gets really warm, and they die prematurely on me. So, but that's your compact fluorescent. There's federal regulation, guys, that banned them. I think they were saying lately that they're not going to produce them anymore. I don't know where they are. The incandescent lamps, they will not be producing them anymore. I can't remember. They stopped making the 100 watt. They're making 75 now. Okay, so there's a lot of regulation related to, there's a big fuss about it a couple of times.
In the next couple of years.
Yeah. The idea is to phase them out of the factory. I don't know, but this is political in the US too.
You don't want to count, you want to have resistance. And there's problems if you have just your whole house is all CFL and your lighting with harmonics and stuff like that.
Yeah. Well, so they're working. Yeah, they're working on the harmonic issues. They supposedly the balance that comes with these compact fluorescent, they have to maintain them within, I think, 5% of total harmonic distortion. If you maintain, like here, these have to be maintained within, I think, 10%, the fluorescent. If you maintain them within 10%, overall effective harmonic is not as big. So anyway, so we're not using them, guys. Also the halogen, then what they do with some of them, they add gases, and they become the halogen they use for special application. In the low voltage lamps, like in refrigerators, low voltage lamps and all these things, the 24 volt lamps, they're still encouraged, but in the high voltage amps, they're not a good alternative. Okay, how are they constructed? You guys are familiar with the incandescent lamps. Here you go. I'm sure you have seen many of them. You have your heater right here, and you put a voltage across your heater, right? Here's your 120 volt, and you heat that boy, and if you put couple of eggs here, here's eggs, right? And you boil. So out of this boy, 80% is heat. And what's 10% is what? Light. So if your intention is to boil a couple of eggs, you got yourself a really nice fixture. If your intention is to light the building like Dunwoody, you will never meet the energy code. Everybody understand that? So here's the construction, like we said. We have the filament, the glass envelope, the filling gas, the lead end wire, and the base, right? So the glass envelope, like you see it, the filament, you burn, the lead wires that you bring the voltage to, and the socket here we can bring the voltage into it. You bring your hot, and you bring your hot and your neutral, right? Any comments about this one? Any comments, guys, about this one? That's the most typical one. So the gas, glass envelope, filling gas, they put certain gases in it, guys, and you got yourself a heater, basically. Okay, characteristics. We have voltages, a lot of them 120 volt, and others wattage. What is it, 300 watt? I don't know if they even, you said they don't make the 100 anymore, but I think they have them up to 300 watts and up to. Shapes, different shapes, they come up, you look at the shapes, they become sizes. Operating characteristics, I think they have 1,000 hours rated to operate, and catalog designations, they have different type of A and B and designations for the catalog. I'm going to show you a couple of pictures about these boys. Okay, so that's my lamps. Low voltage incandescent lamps have small sources. So these guys are encouraged a little bit because there's for certain applications, guys, are tungsten halogen, and they put tungsten halogen in them. So they're encouraged for certain application not to light a commercial building like ours. So we're not going to talk about these. The low voltage incandescent lamps are similar to the incandescent lamps, but these could be used for decorative lights if you're going to be using them. Do you remember in our commercial building, we're using incandescent lamps in one location, right, guys? In the conference room to throw light on the ceiling, on the wall. Now moving all the way to the fluorescent lamps. Fluorescent lamps, Jeff, are called electric discharge lamps. They are arc lamps. They start on arc and maintain the arc, and they convert the arc light into a usable light. Energy saving, high efficacy is one of their more important things, and long lives. That's, my friends, why you guys designed our building with all fluorescent lights. Long life, they live longer, 24,000 hours or so, and also they have higher lumens per watt. So they're more efficient. It will take you longer to boil a couple of eggs on a lamp like this than in incandescent lamps. Construction, you guys know that glass tube with two electrodes at the end and a base to connect them. You heat these electrodes, they start shooting electrons at each other. They hit the molecules of the mercury inside them, and they create an arc. That arc is ultraviolet light. You can't see it, so they have phosphorus. They paint inside of the bulb with some type of phosphorus that convert the ultraviolet light into usable, visible light. And that's how basically you get yourself a lighting source. Any comments, guys? Any questions about these? You're familiar with T8 and T5 and T8 now are the most common ones. Construction inside the tube, as I said, here's what inside your tube that you're familiar with. You have the phosphorus, fluorescent material, phosphorus materials. They get the air out of the vacuum. They have evacuate the air for the most part. They put an inert gas plus a small quantity of mercury. That's where the environmental friendly-ish characteristic becomes. So we have the phosphorus, we have inert gas, and we have some mercury. They create, the way they heat these heaters, guys, they start shooting electrons, they hit the molecules of the mercury, they make an arc, and then by making that ultraviolet light, they convert it through the phosphorus into a usable light. Characteristics, you have the time. Are they straight or looped? Do you have the length, typically input, and the wattage, which you can, and the shape that you can come with different type of shapes, different watts, and different length. Any comments, guys? And we looked at a few of them. I'll show you a couple of pictures of. Any comments? Any questions? They're called arc. They need a ballast. We'll talk about this one. Here's how they typically are, guys. You're going to bring the power into, let's just say the 120 brought here. You heat that filament. That filament starts shooting arc to the other electrode in the other side. In between, you hit the molecules of the mercury, and they will you hit the molecules of mercury. You start your arc, and then that phosphorus material here will convert the light into a usable light. In plain English. Any comments? Any question about the construction of that bulb right here above your head? And again, we're not into the construction, but I want to emphasize a few things. There is the gas. There is the mercury that they put inside it, and phosphorus material that to glow, cathodes that initiate the arcing, the leads that you connect the power to, and there's the bulb, of course, the bulb that house everything together. Any comments? Any questions? Any comments? Any questions about this, Mr. Bulb? So you can imagine that. Fluorescent lamps also have a Kelvin designation. The Kelvin color temperature. The cooler the color, the cooler the color, the higher the temperature. That's the most confusing thing. The cooler the color, the higher the temperature, the more bluish the color will be. Cool? So higher, so if we have higher Kelvin, it becomes whiter or cooler, and of course the opposite, or more bluish, towards the white and the bluish, right? You keep increasing, it becomes almost blue. You reduce the Kelvin. Can you guys see? This is important because you hear Kelvin all the time. The temperature, color temperature of fixture. Very important, guys. So if you have a 5,000 Kelvin here, you're going to have very white bulb. If you have a 3,000 Kelvin, you're going to have a warm white, they call it warm white, more reddish. Are you guys familiar with that? Everybody's good with that? Higher Kelvin, whiter, more almost to the bluish side. Lower Kelvin will get you reddish, more. Lower Kelvin will get you warmer, more to the reddish. All these, Jeff, they have the EPA requirement, guys. They have toxicity factors. So they have to have, each one, the manufacturer have to have a factor that tells all of us how the impact of these products on the environment, the EPA. So rating indicate lamps has passed EPA. So the TCLP, which is characteristic leaching producers or whatever. So that will tell you that this have passed the EPA requirement, and it's not going to make the frogs with 3 legs instead of 4 legs.
Are they still charging to dispose of fluorescent bulbs?
Well, most of the cities in Bloomington, they don't charge you, but if you're a commercial, they do. Commercial, I believe commercial, we pay if you're done with it to discharge them. Residential, no, they don't charge. In Bloomington, at least. I don't know about other cities. I think the Hennepin County, they have a center recycling where you can go to certain areas and you dispose all your electronics and toxic material for free. None, I believe so. Or is it? I know Bloomington
Once in a
does.
while they'll do a free day, bring all your stuff in. Some stuff they do charge you for.
Do they? I know in Bloomington, I took TVs in Bloomington with nothing.
You know, your old CRTs and all that, they'll charge you for.
I was holding up all of my stuff that I have because Dakota County, has that. If you have a Dakota County driver's license, what my parents have, but I didn't think that was.
I might be wrong. I know it's different in Bloomington. You know that we do it. Bloomington, they don't charge you.
96th.
Yep.
And around 96th and 10.
Absolutely. Okay, just to give you guys operation, how does that work? You have the inside the fluorescent lamps. Is coated, and the phosphorus material will convert the ultraviolet light into usable light. When sufficient, so you put, like you guys know, you put voltage across the electrodes, you create the arc, and you maintain the arc by the ballast. You choke the current, you maintain the arc, and the arc that you created is converted into usable light through the phosphorus material. That's in a plain English, explained by a power engineer, not a manufacturing engineer. You need more explanation, you go to the manufacturer of these bulbs. So that's basically it. So electrons, look at that, the electrons strike the mercury. The mercury atoms also have something to do with it. That's why they do it. Then radiation happens when they strike the atoms. And then radiation is emitted from the atoms, and that's where you got your ultraviolet light that you're going to be converted. Radiation converted into visible light. That's the one I need. It's through the phosphorus coating on the tube. Thumbs up, Chad. Nobody's going to ask you to explain that one except maybe on the test. After that one, we know what a T5 is and what fluorescent light is. Where do we use them? We are construction engineers, right? So, but that's basically it. Creating an arc, maintaining the arc through the ballast. The mercury does the radiation after it gets hit by its atoms get hit by the electrons. Does the radiation, ultraviolet light, we can't see it. We have to convert it through the phosphorus coating into a usable light that we can utilize. Otherwise, okay, here's what a really nice explanation with it, guys. You have the hot cathode here, the phosphorus material. Here's the electrons coming out of it, hitting the atoms of the mercury, and then the mercury starts doing radiation. Radiate, and when it hits the surface here, it converts it into usable light. Nice picture explaining it. Thumbs up, Chad. We fully understand that one. And I'm going fast through some of it, guys, because we did a few of them when we did the lighting. So, okay, ballast and ballast circuit. Now, arc fixtures need a ballast. The ballast have two jobs. Kerry, my friend, if anybody asks you, job number one, pulls the voltage up high enough to start the arc. And when the arc is started, if you don't reduce the current, the circuit breaker will trip and think you have an arc fault or a short circuit. Then it will choke the current, reduce it to an acceptable level to maintain the arc without tripping the circuit breaker. That's really what for the most part it does. Electronic ballast, the most popular, you have to use them in a commercial building. You cannot not use them based on energy code. They have to engineer project always electronic ballast, and energy code you can't meet them without. You have to have electronic ballast. Older electromagnetic, like a transformer, high intensity discharge. Also, ballasts are required for high intensity discharge too. They use a lot of electromagnetic with these big lamps. Provide proper voltage to. Okay, here's the most important thing. So you have the proper voltage to start and control the current during the operation of the lamp. These are the most important things about the ballast. Control the voltage, provide higher voltage to start the arc. When the arc is up and running, circuit breaker is waiting to trip. If it continues, it controls the current, reduce the current down by choking it to or altering it to an acceptable level so the circuit breaker does not think it's a short. Can I have thumbs up, Chad, about the ballast? You need them with any arc fixture. Arc fixtures are fluorescent and high intensity discharge. They call them arc. Why? Because they create an arc. They don't heat things. They create an arc. Any comments, guys, about these? Any comments? Any questions? Jeff, I see you looking. You like my handwriting? Okay, special circuits. This is what I would like you guys, the ballast, a few types. They have a preheat, old trigger start. They have rapid start, instant start, programmed start. Look at this. They have dimming circuit. Look, all the ballasts that you can, dimming circuit, flashing circuit, high frequency circuit, and direct current. And I do not claim to be an expert in all of these, but these are the types of ballast that you guys are going to be using. Typically, the ballast that we use, instant start, is a very common one. Preheat is old-fashioned or rapid start. These are the most common ones you're going to find in these. Instant to rapid. This instant to rapid has to do, guys, when you flip the switch, it instantly energizes these cathodes and shoot, and the light will come instantly, right? Rapid means comes fast. Instant means instantly. You flip it, the light, it doesn't sit there. And you guys remember the old ones? T8 used to blah, 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 and flip. These are the preheat days, and have a little starter with it to start it, and then after a couple of seconds it comes to full speed. These are phased out. So you are rapid start or typically instant start. Now the rest of them, programmed start. This is how do you want to control that fixture? Then you have to have a program start for the ballast. Dimming start. If I want to dim this fixture, what do you guys think I need to do? I have to have a dimmable ballast. If you dim this fixture with a regular incandescent dimmer, you will kill it, right? We all know that. So you need, in order to dim a fluorescent fixture, you have to have a ballast that can be dimmed. Can I have thumbs up, Chad? We understand that one? A high frequency circuit and direct current. See, these are all methods, up to my knowledge, guys, of controlling the output of that fixture for so many reasons. Why do you want to control the output? Energy saving is one reason, and also performance. I want to dim it. So a lot of the bottom dimming and programming and high frequency and direct current, all these are methods of controlling the output lumens out of these fixtures for environmental reasons, which is energy saving, or for performance. Can I have thumbs up, Chad? We understand that? So the most common ones are the ones I highlight in red. Okay, a lot of ballasts, guys, have a P factor. This was on a test, if anybody remember. Class P, these are temperature rated. So if the temperature goes higher certain value, it will protect the fixture from temperature. Temperature protection, Class B ballast. Also, they have sound rating and power factor. These are very important ballasts. Sound rating. Do you guys remember the old electromagnet that's used to hum all the time? Really imagine if you're humming over here. Can you do any work? Well, most of us probably can't, right? It's annoying. So that's why the smarter than Ch, the electronic ones don't have a lot of humming, if any. So they assign A through, I can't remember, A through, so A being the quietest, I believe, or the other way around. So they assign a letter value for the ballast, and based on this letter value, it has to either very loud or quiet. And guess what we're going to be providing? The quietest ballast for performance. The power factor right now, you have to produce a power factor. All the ballasts have to have a power factor of 90 or less. In the past, they used to add a capacitor. Do you remember, Jeff? Doing fixtures, adding a capacitor to the fluorescent fixture in order to increase the power factor of it. Now all this have to be done by the electronic ballast. The electronic ballast manufacturer have to maintain a power factor of 90. 90 is good enough, right? That 90 is acceptable by utilities or higher. Any question, guys, about the temperature protection by a Class B ballast? The sound have to be acceptable, as well as the power factor have to be higher than 90. The sound have to be quieter. So these are all factors of your fixtures. Any comments, guys? Any questions for your friend Chad? Comments, any questions? I'm looking for the rating.
A through D on the sound rating.
Okay, A through D, and A is quietest?
Yeah, A's for
the quiet
offices and libraries.
Yeah. A through D, A being the quietest, and D being the most loud. The quietest, of course, going to be libraries and offices, and the loudest ones, what if you have a parking lot, or if you have a manufacturing floor, it's loud anyway, who cares? Okay, good, thank you. So that's important. Then we have compact fluorescent, the ones I hit, Joe, my friend, I put in my house. These are the compact fluorescent. The nice thing about the compact fluorescent, guys, they can replace the incandescent lamps, right? Anywhere, supposedly. Rated life is higher. I start questioning them. Rated life is 10 times higher than their counterparts, the incandescent lamps, and they can produce 3 to 4 times more lumens, more light or lumens per watt, which is great. So they're more efficient and they live longer. Who doesn't want a car that's more efficient and live longer? Or a lamp that's more efficient and live longer? My personal experience with them, I change all my house with them, as I said. If you have a place that has humidity on them, or vibration, humidity, vibration, or heat, they are not good. I put my garage, they love cold. My garage, I've been there for 4 years now. Not a single one of them burned. And of course, places where you switch them a lot more often, therein, if you have a place like bathrooms, you switch them more often, go to the bathroom. If you have kids especially, they tend to diarrhea because you're turning the ballast on and off. How many strikes you strike it on and off, you kill them. Okay, you can have them in 2 arrangement, 2 tubes arrangement. These are the ones that they use for commercial, spiral, twisted spiral ones. You guys have seen them, or a Class E or a Class E ballast. So these are all the characteristics of these compact fluorescent that you can use. Okay, you guys can look at a couple of pictures of different type, twin tube, or there's quad tube and a bunch of others. Okay, so that's what I want to go over. Okay, the second thing, guys, any question about the fluorescent and the incandescent before we jump directly into the high intensity discharge? High intensity discharge, more lumens per watt for floodlights, outdoor, right? That's the major application. Warehouses, and actually the incandescent, the LEDs are taking over them, both. Everything is taken over by the LEDs now. Okay, they are an arc tube light, guys. They produce an arc, bigger arc. They are enclosed in everything is enclosed in a glass envelope, not a steel envelope, because you want the light to come out, right? Mercury vapor lamp, lowest efficacy of the whole family, longer life. Mercury lamps, here's the designation that they do with them, guys. They have mercury lamps, it's phased out. Anybody knows why? Environmental reasons. Not a whole lot of mercuries you can use. I don't think you can use them at all even. They give it the designation letter H. Metal halide, you there? Replacement lamps, okay. But like an engineered project, nobody will do them. When you guys did with me, you put metal halide, remember that term? Metal halide with M, or you need high pressure sodium, and they use L or C, high pressure sodium or HPS. So either high pressure sodium or metal halide are your option when it comes to high intensity discharge. Why do they call them high intensity discharge? The arc is huge. Huge arc, more lumens per watt, floodlights. Comments, questions. Where do I use them? Parking lots is a great application. Warehouses, a great application. Are they there to live? When we go to Davis and Associate, they're telling you all these has been replaced, guys, right now by LEDs. A lot of these fixtures are LEDs. Okay, metal halide. Relatively short lifetime, that's an issue, relatively. So still better than other application. Rapid drop of the lumens output over as it age. The metal halide, as it ages, the lumens start going sharper down. It starts becoming dimmer. So that's a bad characteristics. High pressure sodium is the best, guys, for the most part. The life rating is equal or better than the other lamps, and very stable output over the life of the fixture. So over the life of the fixture, it maintains most of its lumens. When it comes to installing lighting fixture, guys, you are the representative of the customers. They're gonna come to you and give me the best product in the market. So I can get you high pressure sodium metal halide or LEDs. LEDs are the best for us, but if you don't want to pay for the LEDs, the cost, high pressure sodium can maintain its lamps for what, 24,000 hours or so or higher. So, and it maintains the same amount of light. That's good, right? It's not enough for the fixture to be good the first day, guys. You need it. We design systems to live for 40 to 50 years, right? So you want to have a good products that can live over the life of their fixture. Obviously, a lamp is not going to live 50 years. It's going to be replaced, but at least it's going to be replaced every 2 years or so forth. You want it to give the best performance within the expected life of that fixture. Any comments, guys, about high pressure sodium metal halide? Cool. So that's your high pressure sodium metal halide. Low pressure sodium, there's one little problem. Low pressure sodium is very highest efficacy. You can get a lot of lumens per watt, but there's one little problem here. Good luck finding you blue car or green car in the parking lot. Now a lot of people say, Chad, you push that little beeper and get it. They are, anybody say this word again?
Monochromatic.
Monochromatic. I hate that word. Monochromatic meaning they're one color. They don't discriminate between colors. So a good application for this would be, how about highways? I mean, when you're driving at 85 miles an hour, do you really care what color car next to you? You care that there is a car next to you, but you don't care there's an object. Unless you're a police and you will describe a crime. So that could be an application. If you're in a parking lot, you really care about finding your car, right? Among all these thousands of cars. So that's the drawback of this one. And they are the narrow band of yellow. They tend to be yellow. Ballast for the ballast that you can use for high intensity discharge, guys. Typically, electromagnetic ballasts are huge, and here's the watts that you can use them even higher than that. Any comments, guys? Any questions? Metal halide, electromagnetic ballast, bigger lamps, watts up to 500, if not even more than that. Versus fluorescent, guys, you're looking at 32 watt, 40 watt. Actually, they're phasing the 40 watt to 32, and I think now, what is it, 22? I can't remember. I think they're going even 24. They're going lower. The lower the watts, the more efficient the fixture would be. So that's my ballast. Energy policies. We'll talk about all the EPA gas regulation and so forth. EPA. You know for a fact, if you have a commercial industrial building right now, you have to perform an energy calculation. Gentlemen, you did come check with your friend Chad, and most of you did not pass, right? So what does that mean? It means you have to use more efficient fixtures or more way of controlling these fixtures. So as we move forward, the regulation is going to be more tight, in order to maintain and save energy. So be very careful of that one. And lighting power allowances. Lighting power allowances. You guys remember how? Anybody remember in the office? In the office, the code allows you 3.5 for lights, and the energy code allows 1. Was it 1? I think. ComCheck allowed 1 watt per square foot for the office versus the NEC code book 3 volt amp per square foot. So there's a gap between designing a system for safety and designing a system for energy. And our job, you and I, guys, is to bridge that gap. or the engineers is how are you gonna, how am I going to design a safe system and at the same time efficient? That becomes, Jeff, the ultimate, the happy medium that you're supposed to do when you design these systems. Energy saving ballast. Right now, when you, all the ballast have to be in a commercial building, have to be electronic. Look at the power factor, have to be 90 or higher. They have to meet or exceed the standards for energy code, marked with the letter E for efficiency. So you're looking, almost all the stuff that we do in ballast wise for a fluorescent right now are energy efficient ballast, meet the requirement of 90, the power factor, and the harmonic. Jeff, the harmonic, 10% harmonic distortion or less. You want to control the harmonic as well. Okay, so almost all of the stuff that we introduce are going to be energy saving ballast. Energy saving lamps. We talked about, guys, 80% energy, the incandescent lamps. We don't use the incandescent lamps for so many reasons. So right now your options are fluorescent lamps, LEDs, or high intensity discharge. Lighting emit LEDs. LEDs, guys, next project, I promise you, and you promise yourself, all our lights are going to be LED lights. The most efficient. The way the LED, guys, tiny little diodes, you put a tiny little voltage across them and they give you light. Heat is very, very minimum. What they do is they take the 120, convert it to 24 volt and dump it across tiny little diodes, and these diodes will emit light. No heat for the most part. They solve the problem of heat. Vibration, for the most part, they solve the problem of vibration. Long life, a lot of lumens per watt. So they are superior. I'm not going to tell you something that you don't know. There's drawback. The lumens, like everything else, guys, slowly declines as you age. Every fixture, as the fixture ages, the lumens go down. The challenge is how fast it goes down. For example, Aaron, your energy is going to go down. Are you going to lose most of your energy at age 50 or at age 65? That's really what makes a fixture good fixture or bad fixture. How long that fixture can hold most of its lumens. So I know Jamie, my friend, will lose his energy at 59. Your friend Chad, probably at 51, he's dropped. Drop. That's called heart attack. Drop. Okay, so this is just a couple of things that are changing, guys. A lot of these are being replaced right now by the fluorescent, by the LEDs. Disposal, and the last thing is the hazard. We talked about the hazard guard disposal. Of when you relamp your fixture, you have to dispose them in a proper way because they're hazardous material. EPA, Energy Star program, you have to have high efficiency electronic ballast. You have to have timers, occupancy sensor. This is all from ComCheck, guys. And high efficacy appliances, high efficiency appliances. So that's the more where the equipment, including the lights, are going, guys. High efficiency ballast, being able to control the light when you're not using it via timers or sensors, and the fixture itself have to be efficient. The ballast as well as the lamps have to be efficient. Okay, all right, more a couple of this. Okay, I want to show you a couple of pictures and I'm done with that one, guys. Any comments, any questions before I just flash a couple of pictures here? I thought they're really good. There you go. We went through this one, guys. This is how to define the lumen, the lumen over the area. This is my favorite. The higher the Kelvin, can you guys see that one? The higher the Kelvin, the cooler the color. So this right here will be, will be cooler, and this will be warmer. Can you guys see that? So when you have 5 Kelvin, look at this one, 5500 Kelvin, that's close to very white and almost blue. When you have a 3, where's my 3? Here's my 3000 Kelvin. These lamps are 5000 Kelvin or 3000 Kelvin, they call it. And you can see how the color looks like. Can I have thumbs up, Chad? We understand that one? Cool. This is one nice picture of visually indicating. I believe these are 3000 Kelvin. If you have you guys seen, if you've seen one that look blue, almost blue, that's 5000 Kelvin. Anybody likes that?
I've got I got a bunch in my basement, in my
Yeah.
workshop, and the ones that I have in there are 4,000.
4,000.
I prefer actually that as a minimum.
You?
I
Okay.
got more than the yellow.
Yeah, I prefer the reddish type. I don't like that very bright
You like the
white.
yellow?
The yellow, the reddish type, yep. The smaller, that 3,000 Kelvin, I feel, I don't know. It's all about feeling.
I think you
I
can see
feel-
better though with
yeah.
a little bit more blue.
Yeah, but you're right. I think the brighter.
Designed to simulate daylight.
Yeah,
A
absolutely.
lot of manufacturers put them in.
What? I'm having mouth trains.
Okay, gentlemen. This is just two curves to show you the optimum operating temperature of an incandescent lamp. I want you guys to look at this because it's really cool. This is the percentage of voltage. The higher the voltage, the more lumen you can get. But at the same time, the higher the voltage, what happened to the red is the life. The higher the voltage, the less the life of the incandescent lamps will go. The higher the voltage, the more lumen you can get to them. So in order to find the happy medium, this is the point where they cross that happy medium. That's where you get yourself, you operate it at its rated voltage to get its rated lumens, basically. So that's for incandescent lamps and a lot of lamps. I'm not going to sit and tell you guys about all the types of the incandescent lamps that you can use. There's the P's, the A's, the C's. You can see they give them designation letters. I don't know if you guys can see that for different shapes. Look at this shape. This is the most common shape, A, right? All these shapes giving different designated letters for different shapes. One thing I want you guys to know, the number here is actually the diameter. So this is this number is 40 divided by 8 is what? 5. So that's the diameter of that fixture, 5 inches. Okay, everybody now. So take that, any one of these divided by 5 will give you the diameter of that bulb at the largest diameter. By 8. Always divide by 8. Okay, so these are all the designation that they use for them, FYI only. Here's your favorite one. Can you guys see that, how they're dividing them by 8 right here? Everything is divided by 8 to get you the largest diameter. Different type, we talked about this one. Here's all the bins that they use with, when you connect the fluorescent lights, guys, you have your T8, for example, slim line, if you've seen that one. A lot of these are very common here. Medium, T5 and T8 are medium T8 lamp and miniature T5 lamps. A lot of these guys have to do with the way they connect to the base, Here's all the lamps that you can see as fluorescent lamps. The most common ones, for the most part, anybody can pick them. You're going to go to T8 single or T8 medium pins. Can you guys see the pins at the end here, 2 or 1? And where is T5? Do we have a T5 here? Do I see T5? No. So T12, nobody's using T12. T10, I've never seen. I don't think they have them in the catalogs that we have. U's come into. Is it 212? They use T12 for the U?
Yeah.
Okay.
Well, there's both.
So that's the most common ones. It's going to be the T8. And all these are also common for certain application, guys, compact fluorescent. So a couple of applications for them. This is how that works. Here's a ballast. I don't know if you guys can see when you look at the ballast. You can see a lot. But if you look, it gives you the voltage that the ballast is going to work on and tons of other information, regulation, UL listing, and so forth, and the wiring diagram for this ballast. Different ballasts can do different things. Oops, my friends. So here's one ballast driving one lamp. Oh, by the way, you can buy a ballast to drive one lamp, 2 lamps, 3 lamps, or 4 lamps. Typically, after 4 lamps, what do? Thank you. 2 ballasts. How many lamps can I have in a fixture like this? 6, 8. They have fixtures with 6, at least 6. I think they have even 8 lamps driven by 2 ballasts. So, but when we start talking about ballast, a fixture, ballast can drive up to, for the most part, how many lamps? 4 lamps. So here's driving 1 lamp, 2 lamps, different is 2 lamps, different connection, guys. The bases, they have something called, guys, inline fuse. I don't know if you've seen that. This is, if this is a parking lot, typically in the parking lot they use. Suppose that this is your parking lot. What they do carry, my friend, they have inline fuse. First time I was encountered with that one 15 years ago, we did the parking lot. They have a tiny inline fuse. The job of the inline fuse, if this is the parking lot light, do you really want the short circuit in one light to take the whole line? Really? Is that what you guys want? So the Smarter Than Chat, they have a tiny little inline fuse where fuse to protect that particular fixture. So if this goes down, the line, that number, that 20 amp circuit coming here with number 8 conductor, because these are typically number 12 conductors going up, so you can minimize the interruption, right? You would hope so. If a light is too short in the parking lot, do I need to lose all the line there? So for reliability reason, they have in-use light. In use. Here's how it looks like. Jeff, my friend, you bring your voltage here, you bring your hot here, and you take the hot, and the neutral comes to the lighting fixture. That's how typically it does. And if you have a short circuit, that inline fuse right inside the base of your fixture, base of your pole, your lighting fixture, the base of the pole, right, you're going to find that little inline fuse. Any comments, guys, about the inline fuse? Everybody got the word inline fuse? Because the first time I heard it, I said, what the heck, I know what a fuse is, but where's the inline fuse? No, it comes in the base of the circuit. Well, it could be, it depends where, but a lot in the parking lot, you can put them, you can put them here. You can put them for any fixture. The best application for them, the best application is parking lot. Because parking lot, there's a lot of light. So in the base, there will be an enclosure at the bottom of the pole, and you can open it and you can connect the wires. Where you connect the wires, you put them right there, the fuse. So if there's a short circuit, this will be dead. So you know that there's something wrong with it, either the lamp or it's shorted it. So smart that utility maintenance guys open that little box and they check the fuse is okay, and then the lamp is screwed up. You have to go fix the lamp. Makes sense? But can I use them in a fixture like this? Yeah. Is it commonly used? No. Really, do I care if that fixture goes down here? I have tons of other fixtures. In the parking lot, you do care. And how often a short circuit happen in this lamp compared in the parking lot? There's winds and exposed to the elements. So it becomes a reliability issue. Different type, guys, of lamps, like we said. Different type of applications. Okay, so that's basis for lamps. Energy star equipment, everything has to meet energy. I want to say a few things about this, and I'm going to shut off after that. This is my favorite. This one, guys, give you a comparing between all the fixtures. So let's start with the lumen per watt. Incandescent lamps can give you up to 23 lumen per watt. Fluorescent, 100. That's great. If you go to mercury, 65. Go metal halide, 120. High pressure sodium, 140. Low pressure sodium, 180. So you can see how the higher the number, the better the fixture is. Watt, look at the watts that you can get them with. Life is good deal. Incandescent lamps, guys, 8,000 up. You can buy them up to 8,000. But if you go to metal halide, for example, 20,000 hours supposed to live. Fluorescent, 24,000. So that's an advantage. Color temperature, not a big color rendering index. Look how bad the LPS, low pressure sodium, guys, zero. You can't see anything underneath that thing. High pressure sodium, 25. Metal halide is good, 85. The best one, of course, is the worst. Look at that. The best one is the incandescent lamps. Anyway, potential for improvement. They have potential, metal halide potential, fair. So you can improve them by treat them with chemicals. Operating cost. Look at the high operating cost. Lamp cost. Low for the incandescent, moderate, high, blah, blah, blah. Can you guys see the whole thing here? So this is when you do an analysis on your lighting system. These have to put in mind. The operating cost of the fixture, the initial cost of the lamp, the life expectancy of the lamp, the color rendering index, right? How many lumens per watt, the efficiency of the lamps. All these together can lead you to a very simple thing. I'm going to make the decision for you right now. If you're doing indoor, you're right here. And if you're doing outdoor, you're right here. That's what this is supposed to tell you, right? Why don't we use this baby here? Because it's that color rendering index of 0 is bad. Can I have thumbs up, Chad? This is supposed to give me that one. I want to go down to the LEDs, and then they have comparing the LEDs, lamp per watt. LEDs are also great because it gets you a lot of watts and variable things that you can get of them. Watts, color rendering index, life expectancy, temperature, color rendering index is not bad. Lamp cost, a little bit expensive. Operating cost, very low. Can you guys see very low for the LEDs and compact fluorescent? So long story short, my friends, your traditional solutions are these two solutions, and the new solution is right now is what? LEDs. Can I have thumbs up, Chad? We got that one. That's basically what I wanted to show you. Any comments, any questions, my friend? Any comments, any questions? Any comments, any questions? So I hope that was a quick review of what we're going to be doing. I'm going to give you guys 5 minutes, and I really would like to walk you through the software. So go stretch yourself, do that, and then we'll go through the software.